Hello friends, welcome to Simplify Things. Today's topic is risk measures. We will be covering all the three risk measures, but the key focus area would be variance and standard deviation, as that's the most frequently used risk measure. So let's begin. You must have seen this formula in your textbooks, and you must have read that standard deviation is a measure of risk. But how? Meaning how exactly this formula captures the risk. Let me try to explain you that, but for that, first we need to understand what is risk. The most simple and one-word definition of risk I have for you is risk is equals to surprise or unexpected. Let's take an example of investing in stock ABC expecting 10% return over the next 1 year period. Assuming stock actually generated 8% return, this 2% shortfall is surprise to you because you expected 10 while stock generated only 8% return. So a 2% surprise. This surprise or this unexpected part is known as risk. So that's the first key takeaway for us, that risk is equals to surprise. Now the second property of risk is risk doesn't consider the direction of surprise, which means if you are investing in stock ABC expecting 10% return, even if the stock generates 12% return or 8% return, both scenarios are equally risky. Let's try to understand this in more detail. So if the stock generates 12% return, that's plus 2% surprise to you because you expected 10 while you got 12. While if the stock generates 8% return, that's negative 2% surprise to you. Now the basic principle of risk is it doesn't consider the direction of surprise, meaning all these signs are irrelevant. What's more relevant is the magnitude of surprise, which is 2% in both the cases. Hence, both scenarios, whether generating 12% return or 8% return, are equally risky. So that's the second takeaway, that risk doesn't consider the direction. Now this may sound counterintuitive for an investor because he would always prefer getting 12% return over 8% return. But for now, when you have just started studying risk models in quants, you should understand that for a risk evaluation, we are interested in the magnitude of surprise rather than the direction of surprise. Although we have much advanced concepts like semi-standard deviation and value at risk, which consider only the negative surprises. But for now, as a starting point, you should know that risk has no direction. Now we have the last and the third property of risk, but to understand that, we need to first understand the most basic concept used to evaluate riskiness of an asset. Now let's assume that you are an investor and you have to pick any one of these two stocks, and you will choose the one which has the lowest risk. Now the most simple way to compare these two stocks on riskiness is to figure out the ranges in which returns from these stocks are expected to lie. For example, ABC is expected to generate return between 9 to 11% range, and XYZ is expected to generate return between 5 to 15% range. Now let me ask you a simple question, that which one of these two stocks would you prefer to include in your portfolio? Whether you would choose stock ABC, which has a very tight range and hence better predictability, or you would choose stock XYZ, which has a very wide range and hence very low predictability. Meaning, if you invest in XYZ, the range of possible event outcomes are pretty wide, starting from 5%, 6%, 7% up till 15%, and hence a very low predictability. And who likes volatility in his portfolio? So I'm sure your answer is ABC. And interestingly, we can actually assign a numeric value to this property, and we can then use that numeric value to compare different stocks. Let's see how. The numeric value is nothing but the width of this range, which means 2% or 11 minus 9. Similarly, the numeric value of the second stock is 10%, which is 15 minus 5%. The higher the numeric value, the riskier the stock would be. But the question is, how do we actually figure out this range in a stock? It's very simple. All we have to do is look at the past data and pick up the minimum and maximum return. Let's take an example. I'm going to draw a chart for XYZ using historical annual returns. X-axis will have years and so on, and Y-axis will have returns. Let's suppose on year 1, XYZ generated 10% return. On year 2, XYZ generated 7% return. On year 3, XYZ generated 12% return. year 4, XYZ generated 15% return, and on year 5, XYZ generated 5% return. Let's create a line diagram by joining all these dots. So this is how stock XYZ has behaved in the last 5-year period. Now to figure out the range in which all the historical return will lie, all we need to do is pick up the highest point and the lowest point. So this range here, which is 5 to 15, is the range of this stock in which all the historical return from the last 5 years will lie. And the numeric value of the range is maximum, which is 15, minus minimum, which is 5, equals to 10, which is our first measure of risk. So range is equals to maximum minus minimum. Now we can compare the numeric value of range to compare different assets. The higher the value, the higher is the risk. But surprisingly, range doesn't seem to work in all the situations. Let me create a situation for you. Let me draw a similar chart. On x-axis we will have timeline, year 0, year 1, year 2, year 3, year 4, year 5, and so on. And on y-axis, let's plot returns. Now let's assign some values: 10%, 11%, 12%, 9, 8%, and so on. Let's assume this stock generated 10% return in year 1, slightly higher than 10% in year 2, slightly lower than 10% in year 3, and slightly higher than 10% in year 4, meaning this stock has very low volatility. And if we invest in this stock, it's highly likely that we would end up generating 10% or around 10% return for the next 1 year period. But then we noticed the next year stock tanked all of a sudden and recovered immediately, and then followed a 10% return profile for rest of the years. This can happen in a scenario when there is a news out in the market that company might lose one of its key clients, but then the stock recovered suddenly the next day when company clarified to the investors that there is no issue as such, and the news in the market is just a rumor. Now, if you look at this stock closely, for most of the periods, it has generated 10% or close to 10% return. But there was a short period where it experienced a very high volatility. Now in this situation, if you use range to measure the risk in this stock, the numeric value of the range will be very high, and you will conclude that this is a very risky stock, while that's not the case in reality. The stock has very low risk. So what is the problem and what is the solution? The problem is range actually focuses on a very short period of time, while when we are evaluating riskiness in a stock, we should be looking at a very long period of time rather than focusing on a very short period of time. So the key takeaway is, whenever you are evaluating a risk in an asset, you should always take an average risk over a long period of time. So that's our third key takeaway. We should always focus on the average risk over a long period of time. With that, let's move forward to find a better measure of risk. Let me draw a chart for you and you tell me which one is the most risky asset. But whenever we are evaluating the risk, which is surprise, the starting point is the expectation. Let's suppose you expect 10% return from these stocks. So this is a 10% point and this is our expectation line. Now let me draw the first stock. This is stock 1 and this is stock 2. Now which one do you think is most risky? Stock 1 or stock 2? I'm sure your answer is 2. But how? What kind of a calculations you performed in your mind when you said 2 is riskier than 1? I guess you looked at these deviations or surprises or risks and concluded that these risks are higher in 2 over a long period of time, and hence 2 is riskier than 1. Although there are risks in 1 as well, but these risks are very low as compared to 2. So this was very easy to figure out by using a chart. But for an investor, there are a lot of options available to invest. So you may have to compare more than 2 assets on the riskiness, which means it is very difficult to create a chart with those many lines and still be able to read it. So what is the solution? The solution is we need a formula. But the interesting part is we are going to run the same process which you just did when you concluded that 2 is risky. Meaning we will create a formula using these deviations. So let's do that. I'm going to use the same chart of stock in which we were expecting 10% return, and this is our expectation line, and this is how stock has moved. Let's assign some values. This is 11%, this is 13, this is 7%, and this is 9%. This is day 1, this is day 2, this is day 3, and this is day 4. Now remember, our goal is to calculate average risk in this stock, which is a very simple two-step process. Step number 1 is to calculate daily risks. And step number 2, yes, you guessed it right, calculate the average of those risks. Let's do step number 1. Let me create a small table. Day 1, day 2, day 3, day 4, and risks. So on the first day, you expected 10% return, while the stock generated 11% return, which means there is a positive 1% surprise or positive 1% risk. Similarly, on day 2, stock generated 7% return, while you expected 10, which is a negative 3% surprise. Day 3, stock generated 13% return, while you expected 10, there is a positive 3% surprise or risk. Similarly, day 4, stock generated 9% return, so there is a negative 1% surprise. So these are individual days risk in this stock over the last 4-day period. Now the second step is to calculate average. In order to calculate average, we have to first add all these values and then divide by n, which is 4. But you will realize that the sum of all these values is 0, because these negative values are offsetting the positive values. But does that mean the stock here we have has 0 risk, meaning it's a risk-free asset? I don't think so, because a risk-free asset should overlap the expectation line. And we can see all these daily risks. So clearly, this stock is not a risk-free stock. So what is the solution? The solution is property number 2, which says risk doesn't consider the direction of surprise, meaning we should not be interested in these signs, rather we should be interested in the magnitude of these values. So let's ignore these directions. Let me create a new column which says absolute risk. Risk on day 1 is plus 1%, and the absolute of plus 1% will be plus 1%. On day 2, risk is negative 3%, and the absolute of that would be positive 3%. Similarly, day 3, it's plus 3%, and day 4, when the risk is negative 1%, the absolute of that would be positive 1%. Now we have all the positive values, so we can add and divide by n and calculate average. So this value here is the risk value of this stock. Now let's see how we can use this value. Let's suppose this stock is ABC. So the risk value of ABC is 2%. Now let's suppose we perform the same operations for another stock called XYZ, and the risk value is 8%. Now using these risk values, we can compare these two stocks and conclude that XYZ has higher risk. Now think why XYZ would have a higher value. Let's see the math once again. So this 8% is the average of all these 4 values, which are absolute risk values of the original risk values. And these risk values are the function of stock movement, which means the higher the individual day's risk values, the higher will be the absolute number and the higher will be the average. Hence, we can conclude if the risk value of any stock is higher, that stock is riskier. There is another very interesting usage of this risk value. We can use this risk value along with expected return in order to calculate expected range. In our example, the expected range is 8 to 12%. Now one may argue that actual range of this stock is 7 to 13%, which is the minimum return and the maximum return, but that's the actual range. The range which we have calculated is based on the average riskiness. So on any given day, the riskiness could be higher than the average, but on the other days, the riskiness would be lower than the average. So it makes perfect sense to look at the average number when you are studying the stock for a long period of time. Although we have taken just 4 days in our example, but normally in real life, you take a much longer period. This risk value has a name. This is called mean absolute deviation, which is our second measure of risk. Now let's revise our simple two-step process once again. The first step was to calculate daily risks, which is this column. And the second step was to calculate average. Now in order to calculate average, first we have to ignore the sign. So there is an additional step now. Let me include that in our list. So now this simple two-step process has become a simple three-step process. But if you think, there are other ways of ignoring signs as well, like square. So if we take square of all these individual days risk, the resultant values will be all positive. Let's do that. I may have to remove this chart because I would need this part of the page. So let me quickly do that. Let me create a third column which says squared risks. On day 1, the original risk was +1, so the square of +1 would be +1. On the next day, the original risk was -3, so the square would be +9. Third day, +9, and the last day the risk was -1, so the square of -1 would be +1. Now we have all the positive values, so we can add them and calculate average. But remember, this 5 is not the actual risk value, rather this is the squared risk. Meaning you cannot use this 5 the same way you have used the mean absolute deviation value, like in calculating the range. But we can actually perform a simple operation on this squared risk value to arrive at a value which can be used in the same way like we have used mean absolute deviation. And that simple operation is, yes, you guessed it right again, square root. So we will take the square root of 5, which will give us 2.24. Now you can use this 2.24 value the same way you have used mean absolute deviation, meaning to compare different assets to find out which one is the most risky, or to calculate the range. Now this value has a name, standard deviation. And this original value of 5, this is known as variance, which is our last measure of risk. Now let's revise this simple three-step process once again. The first step is calculate daily risk, because that's exactly what your risks are. This column gives you all the daily risks. The second step is ignore sign. Now there are two ways of ignoring signs. One is you can take absolute, or the other is you can do square. So if you take the absolute and you follow the third step, which is calculating average, the value which you get is known as mean absolute deviation. But if you choose to do square and then average, the value which you get is known as variance, which is a squared risk value, and hence you have to do square root in order to get standard deviation. And if you are finding it difficult to remember this simple three-step process, just read the mean absolute deviation backwards. So the first letter is deviation, which is the first step. So you have to calculate daily deviations or risks. The second word is absolute. That's what you use to ignore signs. And the last word is mean, which is your last step. At last, let's look at the complex looking standard deviation formula once again. Now if you look at this formula very closely, don't you think that this is nothing but this simple three-step process? Let's see how. The first step is to calculate daily risk, and we know that risk is surprise or unexpected. So as a starting point, first we need to set the expectation from the investment. And typically, the arithmetic mean based on the historical return is assumed to be a proxy of expected return. So the mean return from the stock is our expectation. Now we will calculate the individual days risk. So this expression here is going to give me all individual days risk. The second step is ignore sign, and since we are deriving the formula of standard deviation, we will do square. So you square all these values to ignore sign. The third step is calculate average, for which you have to add all the values and then divide by n. But this expression gives you variance, so in order to calculate standard deviation, you have to do square root. Thanks for watching the video and stay tuned for our next video.